So today we're going to be talking about modular arithmetic that has to do with mod. So we've been talking a lot about mod. The word mod is short for modulo. So you can say modulo or you can say mod, and it means the remainder after I divide. So when you divide two numbers, okay, sometimes you have a remainder, which is non-zero. Sometimes the remainder is zero. We should always remember that the remainder or the value of the mod should be a positive value. Let's take a quick revision on what we did last time. So for example, if I want to find 7 mod 3, it means if I divide 7 by 3, what is the remainder? Now you can simply do this using octave, or we can do it mentally. So if we try to do it mentally, we can say 7 is equal to 3 times what quotient plus what is the remainder, and through this method we can get the value of the remainder. So how do we get the quotient? Of course we have to divide. So 7 division 3, it's 2 point something. I just take the floor of that, so this is 2. And then I say 3 times 2, this is equal to 6. So 7 minus 6 is equal to 1. Okay, so the remainder is 1. Q in Arabic, ناتج القسمة, and R in Arabic is باقي القسمة. Okay, so we got the value of the mod, we got the value of the remainder, it is equal to 1. So that's an easy example. Let's go to the next example, 5 mod 12. You can see here that 5 is smaller than the 12. So in this case, what is the answer going to be? Let's just follow the steps. 5 is equal to 12 times what quotient plus what is the remainder. So if you divide 5 over 12, it's 0 point something. Or you can ask yourself, how many 12s are inside the 5? Well, 0. So we put a 0 as a quotient, and then you say 12 times 0. This is going to be equal to 0. 0 plus what? I would get to the 5. It is 5. Okay? So you can see here that the value of the remainder, the value of the mod, is equal to 5. باقي القسمة 5. All right. Now you can see that if I have a small number, mod big number, then the answer is the small number itself. Okay, so just put that into your mind. Okay, let's go for negative numbers. Here, negative 21 mod 5. So what we have to do, we just follow the same steps. So negative 21 is equal to 5 times what? Quotient plus what is the value of the mode or the remainder. Now you just go ahead and divide negative 21 division 5. This is going to give you negative 4. So you just try out the negative 4. And then you say 5 times negative 4. This is equal to negative 20. Now negative 20 plus what would give you the R? You can just bring the negative 20 over to the other side just to solve for R. This is going to give you negative 21 plus 20, which is equal to negative 1. So the remainder is negative 1, which is not acceptable because we agreed that the remainder should always be positive. So to rectify this, we can just go to the next number. So instead of negative 4 now, I'm going to put negative 5. So I get a bigger number here that goes to the other side as positive, and I end up with a positive value of R. Okay, so the trick, if it doesn't work, if you end up getting a negative number as a remainder, just go to the next number. In this case, it's going to be negative 5. So we're going to redo this. So I'll try negative 5. So negative 5 times 5, this is negative 25. So if you bring this over to the other side, you would get negative 21 plus 25, which gives you a remainder of 4. Okay, now that is accepted because it's a positive value. All right, so whenever you've got a negative number as a remainder, just try again by going to the next number. till you end up with a positive value of remainder. Now, just a note on how do we find the Q, which is the quotient, and R, which is the remainder. We've already practiced working on this, but just to put them as formulae. So imagine I call this A and I call this B. I want to find an expression in a Q and I want to find an expression in R. So let's start with the Q. How did I find the Q? How did I find the quotient? Okay, simply we said I took the 7 and I divided by 3. So I took the A and divided the A by the B, but then I took only the part which is not decimal. Okay, I ignored all the decimal points and I just took the number. So here we take the floor of the division. Okay, we take just the number and I ignore all this decimals. So that is an expression in a Q. How about R? How did we find R? Well, I found R by multiplying the 3 by 2. Well, I got 6, and then I did 7 minus the 6. So it's basically the A minus the multiplication of the B times the Q. So A minus the B multiplied by the Q. All right, let's go to the next slide. Congruence. So this is a new term. It's a very easy term. What does congruence means? If I say that A and B are congruent and we use this symbol, which is like an equal sign with one more line, this means that A mod N is the same as B mod N. It means if I take A and I divide it by N, I would get the same remainder as if I take B and I divide it by N. Both of them, they have the same remainder if I divide them by N. So we say A and B are congruent mod N. When I divide both by N, I get the same remainder. So here there is an expression, an example on the congruence. So here it says 17, is it congruent to 5 mod of 12? So 17, if I divide it by 12, would it give me the same remainder as if I divide 5 by 12? Well, let's check this out. I'll go ahead and find 17 mod 12. And I'll go ahead and find 5 mod 12. And I'll see, do they give me the same remainder? So you can do this easily in octave or you can do it mentally. Let's just do it in octave for practice. So I'll go and find the mod of 17 and 12. This gives me 5. And for the second one, I have a small number here, mod a big number. So we agreed that this is going to give you the smaller number itself. So 5 mod of 12 is equal to 5. We can see that 17 mod of 12 and 5 mod of 12 give me the same remainder. They have the same remainder. So we say that 17 and 5 are congruent mod of 12. When they're divided by 12, they will give me the same remainder. Let's take another example. 23, is it congruent to 8 mod 15? Means 23, if I divide it by 15, would it give me the same remainder as if I divide 8 by 15? Well, let's try it out. 23 mod 15, what is it equal to? And 8 mod 15, what is it equal to? Well, I can do the first one using octave. So here, what do we have? We have mod, we go ahead here, mod, and then 23, then we have 15, that would give us 8. And of course, a small number 8 mod a big number 15, it gives me the small number 8. I can see that both give me the same remainder when they're divided by 15. It means 23 is congruent to 8 when they're divided by 15, mod 15. Okay, let's take one more example. Negative 182, is it congruent to 5 mod 17? So we're looking, Negative 182 mod 17, would it give me the same answer as 5 mod 17? Well, I know that 5 mod 17 is equal to 5 because a smaller number mod big number gives me the smaller number itself. So here I'm asking myself, negative 182 mod 17, is it equal to 5? Well, I can just do it using octave. So you can go and say mod negative 182 and 17. Is it equal to 5? Well, it is equal to 5. Okay, so we say that negative 182 and 5 are congruent mod 17. All right, let's move on to properties of modular arithmetic. Addition, subtraction, multiplication, and later we're going to be talking about power. So here, these are just some properties that you should know. Although you can do this without the property. So for example, when it comes to addition, you've got two numbers added up, mod a number. You can simply just add them up and see what is the answer, and then you find mod n of that. But the property says, if I have a plus b mod n, this is going to be equivalent to saying a mod n, b mod n, and since they're added, I have to add, and at the end, not to forget mod n. The same thing goes for the subtraction. So the subtraction, I can simply just subtract the two numbers and then find their mod n easily. But the property says a mod n, b mod n. Since this is subtraction, you subtract and then at the end, don't forget about adding the mod n. Multiplication is the same thing. A mod n, b mod n. There is multiplication, so you would multiply and then don't forget about the mod n. Okay, let's take some examples on Moodle. So for example, here you've got two numbers added mod 53. I can simply just go ahead and do it using octave. I can say just mod and then add the two numbers. So I've got these two numbers. I can just copy that. Okay, the addition of them, mod, so comma 53. And it gives me 26. But here they want us to use the property. So what does the property say? It says you take the first one, mod 53. So this is the first one, mod 53. Then you take the second one, mod 53. This is the second one, mod 53. And then what do you do with these two answers? You have to add them up and add mod 53. Okay, so that's what we're going to be doing. I'm going to try for the first one using octave. So we do mod 739, comma 53. This gives us 50, so you just have to type 50. You go for the second one. We want to find mod of 135. The same thing, mod 53. The answer is 29. Now, what do we have to do with these two numbers? We just have to add them up. So here, if you add them up, you would get 79. 50 plus 29 is 79. And then you end up having 79 mod 53, which you can do in octave as well. So I just go ahead and replace this with 79. And you get a 26. All right. So the answer is equal to 26, pretty much the same as the one that we did without using the property. So here we didn't use the property, we got 26. Here, after applying the property, we got 26. It's the same thing for the negative, so I am going to go ahead and use the property. This is going to be 739 mod 55. And then 1776 mod 55. And then I take the two numbers and subtract them, mod 55. So let's go and do the first one. You've got mod 739. And actually, Yeah, let's just go and do it. So this is 55. You get 24, and then you do the same thing for the other number, which is 76. So 76 mod 55, that is 21. Now what do we do with these two numbers? We've got to subtract them. So this is going to give me 3. 24 minus 21, this is equal to 3. So 3, which is a small number, mod a big number, it gives me the small number itself, which is a 3. Now, if you want to make sure that your answer is correct, you can just go ahead and take the entire thing and put it in octave. Without using the property, it would be mod 55. It gives us a 3, which is exactly the same answer. And the same thing goes for the multiplication. So I'll do this one mod 86, then this one mod 86. Then I'll multiply the two answers mod 86. So let's try it out. Here we've got mod 95, mod 86. So that gives us 9. And then you try for the other number, which is 76. And you get 76. And actually, you didn't have to do it because this is a smaller than this. So it gives you the small number itself. Anyways, then you've got to multiply them. If you don't want to multiply them mentally, then you can just multiply them using octave. So here you've got 9 times 76. This is going to give you 684. So you just have to paste that. And at the end, you want to find the 684 mod 86. So you can do it here as well. 684 mod 86. And that gives you 82. Now, if you want to make sure that this answer is correct, you can just do it directly without using the property. So let's do it directly without using the property. So these multiply together, except that the multiplication is an asterisk. And then they want you to find it mod 86. So this is 86. And here you get 82, pretty much as if you use the property. All right, let's move on to something else. So here we've been talking about plus, minus, and times. There's another operation as well, which is raising to a power. So it's basically the same. We start with the thing which is inside. So a mod n. So that's what we start with. So we do a mod n, and then we raise it to the power and not forget about mod n. And this is very important in cryptography في عالم التشفير when you have to find b to the power n mod n, and usually this is going to be high values, it's raised to very high powers. So it's really hard to deal with big numbers directly in octave. It wouldn't give you a precise answer. So we would need to use this property on multiple levels, break the big power down into smaller powers which are manageable and can be calculated. So let's take an example on how to do this. For example, if we have 9 to the power of 51 mod 76, this is a very large number. If you do this directly in octave, you just say 9 to the power of 51, mod of that 76. It's just going to give you a 0 because it's a very large number and 0 is not the remainder. It's not the correct value for the remainder. So how do we deal with this? We are going to express this large power 51 and break it down into smaller powers till we get to the correct power. So we are going to break it down into powers of 2. And to do this, the first step is to take the 51 and express it in binary. Binary is the system of 0 and 1. So it's the system base 2. To get from the decimal, which is 51, into the binary representation, there is a function in octave that is called decimal to binary. So decimal to binary is des to binary to bin, and then you just put the power that you want to break into its components, which are base of 2. So I would put 51, and this is the answer that I would get. Okay, so this 51, which is in decimal, it's equivalent, the same thing as 110011, which is in binary, which is a system of two, base two. So how do we get from here to the power of 51? Well, I'll just take the answer. I know now that 51 in decimal is equal to 1100011 in binary. So this is the binary base 2. Okay, binary means we've got only two digits, 0 and 1. So this is actually the same as, if I want to take it back into decimal, what I have to do is label all these digits. So this is 0, 1, 2, 3, 4, and 5. And then to get its value, what I have to do is take the base 2. All right, so this one is the same as 2 to the power of 5 times 1. And this one is equal to 2 to the power of 4 times 1. This is 2 to the power of 3, but times 0. So anything that is 0 is not going to make any value in my final answer. I can just skip it. Let's go to the next one. This is base 2 to the power of 1. And this is base 2 to the power of 0. So now all of these have to be added up, of course, to get to the 51. So plus, 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 and of course we know that 2 to the power of 5, this is the same as 32, plus 2 to the power of 4, this is equal to 16, plus 2 to the power of 1, this is equal to 2, plus 2 to the power of 0, which is equal to 1. And if you add up all the numbers, 32 plus 16 plus 2 plus 1, this is exactly the same as the original power 51. Okay, so it's the same value, but we're just breaking it down into values which are base 2 because we are going to use the power in terms of powers of 2 to find the value of 9 to the 51 mod 76. Now, eventually, this is only the power. This is only the power 51. Now, we need to find 9 to the 51 mod 76. So, let's just rewrite it. So, 9 to the power of 51 mod 76. This is the same as 9 to the power. Now, I'm going to replace the 51 with the 51 is equal to. It is equal to 32 plus 16 plus 2 plus 1. Okay, and all of this is mod 76, right? So this is actually the same thing. If you add them up, you're going to get this value. Now, on the side, let me just remind you of the rules of indices. If you remember, if I had x to the power of a times x to the power of b, isn't this the same as x to the power of a plus b? I just have to add the two powers up. So if x to the power of a plus b, I can break it actually down into x to the a times x to the b. So it is the same thing here. I have 9 to the power of things added up. What I can do is just say this is equivalent to 9 to the 32. So this is 9 to the 32 times 9 to the 16 times 9 to the 2 times 9 to the 1. And then don't forget about the mod 76. Okay? So this is the same thing using the rule of indices, that if I have something raised to the power of and they're added, I can just say it's the base to the power of this times the base to the power of this, etc. So now we're just going to use the property of multiplication of mod and the property of the power of mod to find the value of this, which is exactly the same as this. So if we go to the next slide, let's just go to the next slide. Okay, so we ended up with this. Okay, that's what we wanted to find. I need to find 9 to the 32 mod 76, 9 to the 16 mod 76, 9 to the 2 mod 76, 9 to the 1 mod 76, and then don't forget to add the mod 76 at the end using the multiplication rule. Okay, So I'm taking everyone for things which are multiplied together. They're all multiplied together. Okay? What I have to do is just take each one the mod and then at the end add the mod. So that's what I'm going to do. All right, now I'm going to start with a small power. So here I started with 9 to the power of 1. And then I'm going to increase squaring the term each time. So 9 to the power of 1 mod 76 is manageable. I can do it by my brain, okay, because this is a smaller number, mod bigger number, so the answer is the small number itself. Now I'm going to square it. So you're going to see each time we're going to square it to get all of these and then substitute. So 9 to the power of 2 mod 76. I just took this one and I squared it. Well, this is very easy to find in octave. I can just simply go to octave and say mod and then 9 to the power of 2 mod what 76. So this is 76 and it gives us the answer, which is 5. Okay, so the answer to this is 5. Now we're going to continue doing this by squaring each time. So if I take 9 to the 2 and I square it, I get 9 to the 4. Okay, 9 to the 2 and I square the 9 to the 2. Okay, I get 9 to the 4. All right. Now, how are we going to evaluate this? We are going to be using the exponentiation modulo. That is, I am going to take the thing, ignore the power for now. I'll just take this and find mod. Then raise it to the power and don't forget about the mod at the end. So here, how do we evaluate this? I'll just take the thing inside the power. This is the power. It's all to the power of 2. So I'm going to ignore to the power of 2 for now. I'll just take the thing which is inside mod and then at the end take all of this, square it. So I took all of this and squared it. And then don't forget about the mod 76. Now you can see that this part, the one that I got from this one, okay, this part is the same as the one from the previous step. So 9 to the 2 mod 76. This is 9 to the 2 mod 76. This is the answer from the previous step. So basically you just take the answer from the previous step, square it, and find its mod. This is the method. Take the answer from the previous step, square it, and find the mod. So I took the answer from the previous step, I squared it, and I found the mod. You can easily find this using your brain because 5 to the 2 is 25, a smaller number than the 76, so the answer is 25. Now we're going to square again. The last step I got 9 to the power of 4. Still, I need to get all the way to 9 to the power of 32 because I need to substitute that. So 9 to the 4, now what we're going to do is square it again. When you square 9 to the 4, you get 9 to the 8. Okay? Square 9 to the 4. 9 to the 4, square it. Okay? Now how do we get the answer for this? We said, I just take the answer from the previous step, square it, and then find the mod. Square it, then find the mod. So that's what we're going to be doing actually here. Each time I'm just going to take the answer from the previous step and then square it mod. So here mod, take the answer from the previous step. So this is a 25. Square it, squared. And then mod 76. So this is 76. All right. So what do we get? We get 17. We got this 17. Now we're going to do the same thing. I need to square it again. So to square it to get every time we're going to be squaring it till we get to the 32. So now how do we get this answer? It's the same thing when you go to octave. All right, I'll just take the previous answer. Okay, you take the previous answer. So now what is my previous answer? My previous answer is 17. So you go 17 squared mod 76, you get 61. This is the answer you got. Now to go to the next one as well, you go and take the previous one. This is the previous answer. You square it and mod 76, you get 73. We got all the way to the 9 to the 32. We stopped because this is the maximum power we need. And now what we're going to be doing is just replace these values of mod, okay, into our first expression to evaluate. So here, what do we have? I have 9 to the 32. Okay, so here we've got 9 to the 32 mod. So 9 to the 32 mod, this is 9 to the 32 mod. Okay, the answer is 73. So I put the 73. Then I need 9 to the 16 mod. This is 9 to the 16 mod. The answer is 61. We get 61. 9 to the 2 mod. This is 9 to the 2 mod. The answer is 5. So I put 5. 9 to the 1 mod. This is 9 to the 1 mod. The answer is 9. I put 9, and then don't forget about the mod 76. Now we can do this easily using octave. I can just say mod. So mod of what? 76. I just need to multiply all these numbers mod 76. So I am going to multiply 73 times 61 times 5 times 9. And this gives me the 49. So this is the answer of 9 to the power of 51 mod 76. Let's take a quick example as well from Moodle. So here, if they ask you compute this, and obviously this is a big power. So we said, what is the first step? Well, the first step is to convert this big power into smaller powers. So what do we have here? I have 19. So decimal to binary, 19. So I would get this, and then I should not forget that this is going to be labeled 0, 1, 2, 3, and 4. And then I have to just break it down so we can say, I can add a comment here just to help us understand. So if I just